Hello friends, welcome to Easy Maths. This is the continuation video of part 2 about introduction to ratios and proportions. So in our previous video, we discussed about ratio of two quantities and division in a given ratio. In this video, we are going to learn about comparing ratios and about proportions. Comparing ratios. So like we did in our previous video, the ratio 4 to 8 can be written as 1 to 2. So which is the simplified format of 4 to 8. So 1 to 2 expresses the ratio in the lowest terms or in the simplest form. Since A by B equals MA over MB for any natural number M, the ratio A to B equals to the ratio MA to MB. That is, the value of the ratio remains the same if the first term and the second term are multiplied or divided by the same quantity. So here the same quantity is M. So we are multiplying the ratio A to B by M for both the terms A and B. But still, we get the same value, which is A to B equals MA to MB. So not only multiplication, we can also perform division to get the same value for the ratios. So let's consider the ratios 3 to 4 and 6 to 8. Are they equal? The ratios are equal if 3 by 4 equals 6 by 8. These are equal if their cross products are equal. That is, if 3 times 8 equals 4 times 6. So we got 3 times 8 by, equal to 4 times 6 because 3 by 4 equals 6 by 8 can be changed into cross product like 3 times 8 which equals to 4 times 6. So the 8 goes this side and the 4 goes the other side. So it's actually the inverse operation. So if this is true, then the ratios 3 to 4 and 6 to 8 are equal. Since both these products equal 24, the answer is yes, the ratio are equal. Remember to be careful, order matters. So a ratio of 1 to 7 is not the same as a ratio of 7 to 1. Examples 1. Are the ratios 7 to 1 and 4 to 81 equal? No, because 7 by 1 is greater than 1, but 4 by 81 is less than 1. So the ratios can't be equal. Are ratios 7 to 14 and 36 to 72 equal? So if we consider these ratios, notice that 7 by 14 and 36 over 72 are both equal to 1 by 2. So if you simplify 7 by 14 and 36 by 72, you'll be getting 1 half, which is 1 by 2. So the two ratios are equal. To compare two ratios, they need to be to be first written in the simplest form, and then their denominators, when written as fractions, have to be made equal. So in order to compare two ratios, first they need to be made into the simplest form. Here we got 1 half by simplifying 7/14 and 36/72. So let's move on to the next example. So in two examinations, Shalami scores 40 marks out of 50 marks and 70 marks out of 80 marks respectively. In which examination was her performance better? So here two sets of numbers are given to compare. So the ratio of the marks in the first examination is 40 to 50 or 4 to 5, or which can also be written as a fraction as 4 by 5. The ratio of the marks in the second examination is 70 to 80 or 7 to 8, or with the fraction notation 7 by 8. The least common multiple of the denominators 5 and 8 is 40. So if we consider the two fractions which we got, so these are the two fractions of the ratios of the marks Shalomi has scored. So the denominators are 5 and 8. So what we do is to find a least common multiple of 5 and 8 so that we can compare using the same denominators, so which is 40. Now 4 by 5 equals to 32 by 40, where we multiply the bottom by 8 to get 40, and whatever we do to the denominator, we have to do it to the numerator. So we multiply the 4 by 8 to get 32, and 7 by 8 equals 35 by 40, where we multiplied 8 by 5 to get 40 and 7 by 5 to get 35. So now we have the two fractions 32 by 40 and 35 by 40. So it's easier to compare where we have the same denominators. Thus, Shalomi performed better in the second examination. Proportion. A proportion is an equation with a ratio on each side. It is a statement that two ratios are equal. 3 by 4 equals 6 by 8 is an example of a proportion. When one of the four numbers in a proportion is unknown, cross products may be used to find the unknown number. So this is called as solving the proportion. Question marks or letters are frequently used in place of the unknown number. So if you consider an example to solve for n, 1 half equals to n by 4. So the unknown term here is n. So we can find the value for n by using the cross products. So in 1 half, which equals to n by 4, if we perform the cross production, the 2 goes to the next side and the 4 goes to the other side. So which is done as the cross production, which would give you 2 times n equals to 1 times 4, which equals to 4. So 2n equals to 4. Now we have 2 with the n, but we need to take n separately to one side. So what we do is to do the inverse operation in order to take away the 2 from the n. So both the sides we divide by 2. So n equals 4 by 2, so that n equals 2. Okay friends, so let's try exercise 1. Suppose the distance between two cities measures 2.5 centimeter on a map. The scale on the map is 1 centimeter to 10 kilometers. How far apart are the cities? So let's start by underlining the important keywords. So the distance between the two cities measures 2.5 centimeter on the map. The scale on the map is 1 centimeter to 10 kilometer. How far apart are the two cities? So we are asked to find the actual distance between the two cities whose distance on the map is 2.5 centimeter. So if 1 centimeter equals to 10 kilometer in real, so we are asked to find 2.5 centimeter in the real distance. So what we can do is we can times the 1 centimeter by 2.5. So whatever we do on this side should be done on the other side. So we'll be timesing 10 kilometers by 2.5. So which would give us 25 kilometers. So the actual distance between the two cities is 25 kilometers. Okay, so let's move on to the next question. Exercise 2. Two cities that are 15 kilometers apart appear on a map 4 centimeters apart. What is the scale on the map? So now is the other way around. So a distance on the map is given and the distance in real is also given. So which is 15 kilometer in real is given as 4 centimeter on the map. So we are asked to find the scale on the map. So which means the scale on the map normally starts with centimeters because on the map the measurement given is in centimeters. So we usually write the centimeter value first and then the kilometer next when we are mentioning on the map. So 4 centimeter to 15 kilometer. So 1 centimeter to the missing number. So how can we get 1 centimeter from 4 centimeter? Simply by dividing 4 centimeter by 4. Similarly, so whatever we do on that side should be done on the other side. So we'll be dividing 15 kilometer by 4. But 4 doesn't go into 15 without any remainder. So it has remainders if you divide 15 by 4. So in order to avoid that remainder thing, we can do 15,000 meters. So 15 kilometer equals 15,000 meters. So we can divide 15,000 meters by 4 and mention it in meters. So if we divide 15,000 by 4, so 4 goes into 1 0 times and 4 goes into 15 3 times with a remainder of 3. So which means 30. So 4 goes into 30 7 times with a remainder of 2. So 4 goes into 20 5 times and you'll be getting 3,750 meters. So the ratio or the scale on the map is 1 centimeter to 3,750 meters. And you can also mention it in kilometers if you want. So 1 centimeter equals 3.75 kilometers. So which is when you divide 3,750 by 1,000. So both of them are correct. So let's move on to the next question, exercise 3. If a person is paid a commission of 15,000 rupees on the sale of a house worth 3 million rupees, what would his commission be on the sale of a house worth 7.5 million at the same rate? So let's start by underlining the keywords. So the commission is of 15,000 rupees on a sale of a house worth 3 million rupees. What would the commission be on sale of house worth 7.5 million at the same rate? So for every 3 million rupees or the sale of every 3 million rupees, a commission of 15,000 is given as commission. So we need to find the commission given for 7.5 million rupees of sale. So let's start with 3 million. So 3 million rupees to 15,000 rupees. And here we have 7.5 million rupees and we need to find the commission given for 7.5 million rupees. So by multiplying 3 we can directly get 7.5, but we can't be multiplying by a whole number because 7.5 is not in the times tables of 3. So what we can do is we can reduce the number 3 to 1 simply by dividing 3 million by 3, which would give you 1 million. And whatever you do on that side, you'll be doing it on this side, which would give you 5,000. So now we have the commission for 1 million, which is 5,000, and we times it by 7.5 to get the commission for 7.5 million rupees. So 5,000 times 7.5. So let's calculate the value for 5,000 times 7.5. So which would give you 37,500. Yes. So that is the commission for a house worth of 7.5 million rupees. All right, so let's move on to the next part of this lesson, percentages. When comparing fractions, it is often convenient to express them with a denominator of 100. Fractions with a denominator of 100 are called percentages, and the numerator of the fraction is called the rate percent. So it is always easier to write a fraction with a denominator of 100. And to convert a fraction into a percentage, we always need to have a denominator of 100 in a percentage in a fraction. So if you consider 2 over 5, so we have 5 as the denominator. In order to change this into a percent, we need to have a denominator of 100. So I'm directly writing 100 over here. And what we can do to get 100 from 5 is we times by 20. So whatever we do to the denominator, we'll be doing it to the numerator. So 2 times 20 would give you 40. So that's how we got 40 over 100. And in a fraction, if the denominator is 100, you can directly write the numerator as a percent. So 40 over 100 equals 40%. And the percent can be replaced by the symbol percentage, which is usually used to denote the percent. So to convert a fraction into a percentage, we need to multiply the fraction by 100%. Thus, in the example, so you can get a fraction having a denominator of 100 and then you can change it into a percentage, or else you can directly times by 100 percentage, which would directly give you 40 percentage if you solve this calculation. Okay, friends, so let's try exercise 4. On a certain day, 4 students from a class of 32 students were absent. What percentage of students was present on that day? So there were 4 students from a class of 32 students were absent on that day. So what percentage of the students were present on that day is the question. So we know the number of students who were absent, which is 4, and we know the total number of students, which is 32. But we are asked to find the percentage of the students who were present on that day. So to find out, we take away the number of absentees from the total number of students. So which is 32 take away 4, which is 28. So now to find out the percentage, first we'll write down the fraction of the number of students who were present. So out of 32, 28 students were present and we times it by 100 percentage in order to get the number of students as a percentage. So we know that 4 can go into 28 and 32. So to simplify 28 by 32, we can divide the top and the bottom numbers of the fraction by 4. So 28 divided by 4 would give us 7 and 32 divided by 4 would give us 8. So that's the simplified form of the fraction 28 over 32 and we times it by 100 percentage, which would give you 87.5 percentage if you simplify the calculation. So let's move on to the next question. Exercise 5. 8% of the apples in a box containing 75 apples were rotten. How many apples were rotten? So 8% of the apples in the box containing 75 apples were rotten. How many apples were rotten? So if the number of apples in the box are 100, we'll be having 8 rotten apples. But we have 75 apples in the box. So in order to find the number of apples out of 75 that are rotten, so if we have a total of 75 apples, to find out the number of apples which are rotten, we do 8 over 100 times 75 because 8 percentage of the apples in the box containing 75 apples were rotten. So 25 goes into 100 four times and 25 goes into 75 three times and 4 goes into 4 one time and 4 goes into 8 two times. So 2 times 3 by 1 would give us the number of apples that were rotten, which is 6. So 6 apples out of 75 were rotten. Exercise 6. 6% of the children in a school caught an infectious disease. If the number of children who caught the disease is 48, how many students are there in the school? So 65, 6% of the children in the school caught the infectious disease. If the number of children who caught the disease is 48, how many students are there in the school? So we know that 6% of the total number of school have got the disease. And also we know that that is 48 students. So to make a calculation, so 6 out of 100, so 6% equals to 6 over 100 of the total would give us 48. So we have to find the value for t, which is the total number of students in the school. So in order to do that, we need to get rid of these 6 and 100 from the t. So that t would be there as a ln on the side. So to do that, we times both the sides by 100 to get rid of the 100 with the t. So which would give you 48 times 100. And we have a 6 with the t. So to get rid of the 6, we divide both the sides by 6. So 60 divided by 6 would give you t, and 48 times 100 divided by 6. So 6 goes into 48 8 times and 6 goes into 6 one time, which would give you 800 students. So the total number of students in this school is 800 students. So that's it for this video, my friends. So if you like the video, press the like button, and if you have any question related to what we have learned today, please put them in the comments and also subscribe to the channel. Thanks for watching.